Hello friends, welcome back to my channel. So in this video, we are going to see how to calculate a electrochemical double layer capacitance, electrochemically active surface area, specific capacitance and roughness factor from the cyclic voltammetry. But before that, please subscribe to my channel if you are not subscribed yet and don't forget to press the bell icon. So let's start our today's video. So today we are going to calculate these four terms, that is electrochemical double layer capacitance, electrochemically active surface area, roughness factor and specific capacitance. So first of all, let us see the formulas for all these four terms. So for electrochemical double layer capacitance, its formula is anodic slope minus cathodic slope and whole divided by 2. And for electrochemically active surface area, it is double layer capacitance divided by specific capacitance. And for roughness factor, it is electrochemically active surface area divided by geometrical area of the electrode. Fourth, the specific capacitance of the catalyst, and its formula contain the area inside the CV, which we will see in further video, divided by twice the voltage difference multiplied by mass of active material and multiplied by its scan rate. Okay, so starting with the first one, that is electrochemical double layer capacitance, we will calculate. So for this we need a cyclic voltammetry recorded at different scan rate in the non-Faradic region. So you can see that we have Excel file of containing CV recorded at different scan rate, which I have already pasted in the origin workbook, and I have converted the current column into current density already. And let's plot this. So after plotting we will get this type of graph. Then we need to choose a line over which we will take the current density. So let's zoom in this region and select this point, and by clicking here you can see you will get the value of current density y value. Now note all these points at different scan rate for anodic region and similar in the cathodic region. So I have recorded it already. Now take another workbook and paste it here, or write it here. You can see I have made the column with scan rate, then all the anodic point which I have get at respective scan rate I have mentioned here in the anodic as well as in the cathodic column. Now plot this. So you will get this type of plot. Now first of all, let me increase the size of this point for clear visualization. Okay, now what we need to do, just click on point, just click on point. Now go to analysis, then fitting, linear fit, and open dialog box. Okay, now press OK. So you will get this table. Let me zoom in. So here you will get the slope value for both anodic and the cathodic current density. So initial one is the slope for anodic region, that is 9.95 into 10 to the power minus 4, and slope for cathode is minus 7.205 into 10 to the power minus 4. This way we have got the value of slope. Now we need to obtain the r square value. So for that we need to plot both the graphs separately. So let's plot this and go to analysis, and we need to fit it similarly. Okay, now we will get one table here. Just zoom in on the table and you will get the r value, that is 0.963. So similarly we have to do for cathodic current. So here we get a r square value, that is 0.89 for the cathodic current density. Now we will take the slope value for both of the anodic slope and cathodic slope. So we have to divide it by 1000. So we will get the value of cathodic slope and anodic slope, that is 0.09 and 0.72. So it is supposed to be minus 0.72. So by mistake I have wrote it 0.72. Now put it in formula and we will get the electrochemical double layer capacitance value, that is 0.886 Faraday per centimeter square. Now what we can do, we will take this graph, just zoom out. Now we can use these two graphs for the data which we can give in the paper by editing this. I will show you. Yes, we can, after editing these two figure, we can use it in the publication article in the image form. So here we need to mention all these things. You can also refer some paper where you can see like this scan rate graph is given with this scan rate dependence CV. Now coming back to our further calculations. Now second calculation is electrochemical active surface area. So here we have now CDI value and we need to divide it by specific capacitance. So this specific capacitance is different for different material. So from literature I know that for my electrode it is 0.035. So I took it directly and divided the CDI value, and I have get the electrochemically active surface area, that is 24.57 centimeter square. Now for the third, that is roughness factor, we have to divide the electrochemically active surface area by its geometrical area. So for my electrode, that is glassy carbon electrode, the geometrical area is 0.071 centimeter square. So I have divided the 24.57 by 0.071, and I have got the roughness factor, that is 347.07. Now moving to our last, that is specific capacitance of the material. So for this we need to calculate first area. So one thing I want to mention here, that the CS is the specific capacitance of the electrode, and this specific capacitance what we are calculating are for the catalyst. So for calculating area inside the CV, we need the CV here. So let's take the CV at the scan rate 100 millivolt per second and plot it. Now select it, go to analysis, mathematics, then polygon area, and here you need absolute area. So after clicking you will get the value, which is 0.084. Now we have area, that is 0.084, and catalyst I have took here for the sake of convenience, that is 1 mg, and here we need to take it in gram, so that's why we can take it 0.01 gram. And the voltage difference, so as we have took the potential, that is 0 to 0.4, that's why voltage difference will be 0.4, and scan rate is 100. So you can take any CV at a different scan rate and just take that value here. So now by putting all this value, you will get the specific capacitance for the catalyst also, which is 1.05, and the unit is farad per gram. So in this way you can calculate all these four entities from the single graph of CV. And thank you friends for watching our video. Please like, share, comment and subscribe to our channel if you are not subscribed yet.